Okay, this is part 2 of rational exponents. Let's do a couple review problems from just the previous lesson. 64 to the 1/2 power. We learned that a to the 1/2 power actually means square root a, and so this is the square root of 64, which is 8. Negative 64 to the 1/2 power. The negative sign is on the outside, so this is negative 1 times the square root of 64, which is negative 1 times 8, negative 8. Negative 64 to the 1/2 power. The negative sign is inside the parentheses, and so it's going to be under the square root sign. This is the square root of negative 64, and that is not a real number. Remember that we cannot take the square root or actually any even root of a negative number. We also learned that in general, a to the 1 over n is the nth root of a. For example, 125 to the 1/3 power. That means the cube root of 125, which is just a 5. 16 to the 1/4 power. That means the 4th root of 16, which is a 2. And one more here. How about negative 1 to the 1/5 power? That's a 5th root. So that's the 5th root of negative 1, and that would be actually negative 1. We also learned that if we have a to the fraction m over n, that is the nth root of a, then raised to the m power. Or you could have the m exponent inside with the a. Either one is acceptable. This is in m here. Some examples of that. 16 to the 3/2 power. Writing that in radical form, that is the square root of 16, then raised to the 3rd power. Notice here the 3/2 right there. This is, the square root of 16 is 4, raised to the 3rd power is 64. 27 to the 2/3. That in radical form is cube root 27, then raised to the 2nd power. The cube root of 27 is 3. You square that and you get 9. Write as a radical. 13 to the 1/5 as a radical is the 5th root of 13. Can't really simplify that. 9x to the 5/8. Notice that the 9 is on the outside. That's 9 times the 8th root of x to the 5th, just like that. If I have 9x all raised to the 5/8 power, the 9x is in the parentheses, then everything is under the radical. This will be the 8th root of 9x, and then that's raised to the 5th power. I'll put the 5th power on the outside this time. We call negative exponents, for instance, 25 to the negative 1/2 power. To make an exponent positive, we flip over the number, reciprocal that is. This is 1 over 25 to the positive 1/2. This is 1 over the square root of 25, which is 1/5. 16 to the negative 3/4 power. To make the exponent positive, I flip over the 16, 1 over 16 to the positive 3/4. Now writing this in radical form, we have 1 over the 4th root of 16 cubed. The 4th root of 16 is 2, and then we cube that, we get our answer of 1/8. Here's another one. 4 to the negative 5/2. To make the exponent positive, I flip over the 4. 1 over 4 to the positive 5/2. Then I write this as a radical. This is 1 over the square root of 4 to the 5th. The square root of 4 is 2, so this is 1 over 2 to the 5th, which is 1 over 32. Simplify. Excuse me. The square root of y to the 10th. Now, we're going to assume here all variables are positive. That way I don't have to worry about any of those absolute value problems. The square root of y to the 10th. Now how do I simplify that? One way I can do it is to write it as a fractional exponent. In other words, I go in the reverse direction. Notice with the square roots that the index is actually a 2. So as a fractional exponent, this is actually y to the 10 over 2. I'm going in the reverse direction from what I've been doing. Now y to the 10 over 2, the 10 over 2 reduces to 5, so this is y to the 5th, just like that. Here's another one. The cube root of x to the 12th. To simplify this, I'm going to write this as an exponent, a fractional exponent. So this is x to the 12 over 3, and that is x to the 4th power. The 4th root of t to the 4th, writing that as a fractional exponent, that is t to the 4 over 4, which is a 1, so this is just t to the 1st. All of the rules of exponents still apply. For example, if I have x to the 1/2 times x to the 1/4, I add my exponents together just like I normally would. So this is x to the 1/2 plus 1/4. Getting a common denominator, that's x to the 3/4, just like that. And if required, you could write that as a radical. 5 to the 2/3 over 5 to the 7/3. Now in a situation like this, we're supposed to subtract our exponents. So I'm going to take this exponent minus that exponent. So this is 5 to the 2/3 minus 7/3. 2/3 minus 7/3 is negative 5/3. So this is 5 to the negative 5/3 power. If you want, you can write that as a positive exponent. This is 1 over 5 to the positive 5/3. You can even write that as a radical. Here's some more. 11 to the 3/4 times 11 to the 5/4. We add our exponents together to get 11 to the, this is supposed to be a 4 here. Let's fix that. 3/4 plus 5/4 is 8/4. And 11 to the 8/4, that's the same as 11 squared, which is 121. 7 to the 3/4 over 7 to the 7/4. we subtract our exponents in this sort of situation. This is 7 to the 3/4 minus 7/4. That's 7 to the negative 4/4. That's really 7 to the negative 1 power. And 7 to the negative 1 power is 1 over 7. Excuse me. Simplify. This is some more here. X to the 1/2, y to the 2/3, all to the 4th power over y. Just following our properties of exponents that we learned in the previous section, I distribute that 4 exponent, and remember that we multiply here our exponents. And so this is x to the 1/2 times 4, y to the 2/3 times 4, over this y to the 1st power. Multiplying, that's x to the 2, y to the 8/3 over y to the 1st. Now I'm not quite done yet, because what I can do now is reduce these y's here. In a situation like this, we subtract our exponents. So this is now x squared times y to the 8/3 minus 1. Well, 8/3 minus 1 is the same as 8/3 minus 3/3. So this is x squared y to the 5/3 power. Just like that. Let's try another one like this. Nine to the 2/3 times x to the 1/3 to the 4th power over 9 to the negative 1/3. First of all, I have this 9 to the 2/3 over 9 to the negative 1/3. I can subtract my exponents. So this is 9 to the 2/3 minus a negative 1/3. Subtract the exponents. Times. Right here, I'm supposed to multiply those exponents together, and so that gives me x to the 4/3. This is really 9 to the 3/3, if you add those fractions, which is really a 1. So this is 9x to the 4/3 power. A to the 2/3 times a to the 7/3 plus a to the 1/3. I'm supposed to distribute the a to the 2/3. So that times that. A to the 2/3 times a to the 7/3 plus this times this. A to the 2/3 times a to the 1/3. Now remember, in this sort of situation, I add exponents. So this is a, this right here, is a to the 2/3 plus 7/3. And the next one is a to the 2/3 plus 1/3. Adding our fractions together, this is going to be a to the 9/3 plus a to the 3/3. That's a cubed plus a. Okay, now let's look at some with radicals. Simplify. The square root, or the cube root of x squared times the 4th root of x. To multiply these two radicals together, what I can do is first write them as fractional exponents. The cube root of x squared as a fractional exponent, is x to the 2/3. The 4th root of x is the same as x to the 1/4. Now that I've written them as fractional exponents, I can now add those exponents together. This is x to the 2/3 plus 1/4. Got to get a common denominator, which is 12. So this is going to be 8/12 plus 3/12. Adding those together, that's x to the 11/12. Now, I could leave it like that, or since the original problem was in radicals, I can write that as a radical. So, or x to the 11/12 power is the 12th root of x to the 11th. So either this is acceptable or that answer is acceptable. Let's look at another one like this. The 5th root of m cubed times the square root of m. Okay, I'm going to write those first as fractional exponents. This is m to the 3/5, and this is m to the 1/2. I add my exponents together, m to the 3/5 plus 1/2. Getting a common denominator, which is 10, this is now m to the 6/10 plus 5/10. That is m to the 11/10. And then we could also write that in radical form. That's also the 10th root of m to the 11th. Couple more. Simplify. The square root of x cubed over the cube root of x squared. Once again, to simplify this, I'm going to write each one as a fractional exponent. This one right here is x to the 3/2 power. This one is actually x to the 2/3. If I subtract those exponents, that's what I'm supposed to do. This is x to the 3/2 minus 2/3. Let's go back up here. Now, common denominator would be 6. So this is going to be x to the 9/6 minus 4/6, which is x to the 5/6 power. I can write it like that. Or, in radical form, this would be the 6th root of x to the 5th. Either one of those is an acceptable answer. One more. 4th root of the cube root of x. So I'm going to write each part as a fractional exponent. This is the 4th root of the cube root of x is actually x to the 1/3. Now a 1/4 power means x to the 1/3 is being raised to the 1/4. The 4th root means a 1/4 exponent. In a situation like this, we are supposed to multiply our exponents together, and so this is x to the 1/12. You can leave the answer like that, or in radical form, this would be the 12th root of x. And that ends our lesson on rational exponents.